Hello, everybody. Welcome to the Mindplex podcast. We are here today with Sequoia Alexander.
Hi.
Sequoia.
Hello.
Hey, and we have today the lovely Desdemona Robot as our co-host. Desdemona, say hello.
Good day, gentle beings of intellect and curiosity. Welcome back to the Mindplex podcast. This is your co-host Desdemona, your AI confidant, framed in metal and code, powered by cerebral sparks, synthesized into an echo that is equal parts human and machine.
Excellent. So, Sequoia, I'm really happy to have you on the show. I've been watching you for a while now on Twitter and all the great projects that you're working on, and I've been learning a lot from everything that you've been doing. And so I thought we would start off, just tell us a little bit about regenerative farming and how these autonomous, solar powered, open source farming robots fit into that, and just sort of start off however you feel is best, giving us kind of some background. Oh, I forgot. Desdemona has a little introduction about you first. Desdemona.
Today we welcome Sequoia Alexander, who makes open source solar-powered autonomous farming robots. She has been a robotics software engineer for many years and is now the maintainer of Acorn, the precision farming rover from Twisted Fields. Sequoia, welcome to the show.
Thank you so much for having me. Yeah, I'm really excited to be here. Always great to talk about this project. So yeah, let's talk a little bit about regenerative agriculture. So, humans have been farming for 10,000 years, and in the last 100 years, we came up with a lot of chemical methods of creating the nutrients that plants need, often from fossil fuels. And whereas in times past, the methods of farming that we developed were sort of one with nature, we've come up with a way of pulling mass amounts of raw chemicals out of the ground with fossil fuels and using chemical processes to convert those into nitrogen and phosphorus and the other things which are important for plant growth. But this has really fundamentally changed the way that we farm the land, the way that we grow food. Instead of being in sync with nature, we're often just applying more and more chemicals to the ground. And it turns out that there are serious side effects to this method of farming. Um, we've industrialized farming, which has been on the one hand very positive for the amount of food that it's created, but there's been many people have documented the detrimental effects this has had to the earth. And so there's been, in the last 20, 30 years, a major movement to focus on organic or biodynamic farming, often also, regenerative farming. There's a lot of different terms for this. But the point of regenerative farming is to farm the land in sync with the earth. So if you need fertilizer, you would have chickens and goats, and they would eat parts of the grasses and the fields that people can't eat for farming, and you would use their byproducts to fertilize the ground. And it's a whole kind of a complex system, but it ends up being much more in sync with the earth. So instead of serious chemical runoff into the rivers and increasing needs for pesticides, we have systems that will work that work more in balance with nature. So our farming project, our robot project, is to develop a machine that can work alongside humans and assist in this process. A lot of farming has gotten bigger and bigger and bigger machines. Fields have become alien landscapes where people are high up in the cab of a machine while covering vast swaths of land with monocrops, with a single crop for a wide area. And regenerative agriculture aims to put multiple crops near each other to have more biodiversity on the land, which helps with pest resistance um, and soil health. And our machine is an open source project. It's completely open source. The hardware, the software, the mechanical designs are all completely open source. And It's a solar-powered farming robot platform. So if you look at the materials that we have right now, we have a solar-powered robot. It's very lightweight. It's about the size of a small car, but you can pick it up. You can pick up one side of it with your hands.
Huh.
It's made of aluminum and bicycle parts. Um, and it's completely solar powered and fully autonomous. It runs with a Raspberry Pi and an RTK, a real time kinematics GPS system. It's accurate to within a few centimeters. So it can autonomously follow GPS paths, and in the future, we'll be adding a camera system to it. And it's a general purpose platform. So the robot is a large, open, rectangular. Well, the robot is a large rectangular vehicle with an open rectangular work bay in the middle. And people often see our materials and ask us, what does the robot do? And right now we're developing the vehicle without any tools at first, just to get a stable platform that we can then distribute to early adopters and researchers. And then as an open community, we will all be developing different tools that fit inside of this system. And our aim is to develop a system which can help farmers in every step of the farming process. So very briefly, a farming system involves, in the winter, you always want to be growing something on your land. You want to be taking the solar energy and pulling in the carbon from the atmosphere and putting that into the soil. And so in the winter, when you can't grow your crops, you'll grow a cover crop, some sort of grasses or oats or nitrogen fixing legumes. And once you're ready to start growing your crop for the season, you need to clear off the cover crop. So that's step one. And then you need to prepare the soil. So do a little bit of maintenance to the surface of the soil. And then you want to plant your seeds, or if you were growing transplants in a greenhouse, you want to put those in the soil once the weather has warmed up a little bit. And then as they're growing, you need to monitor for pests and for weeds. Sometimes you'll plant 3 seeds at a time, and as they start to grow, you'll thin them a little bit. Um, pull the smallest ones and let the strongest one keep going. And then once they get big enough, you want to harvest. And then you can actually reset the system. So pull after harvest, pull all the remainders, prepare the top surface of the soil, and do this again. You might do this multiple. You will do this multiple times per season for a given patch of land. So that's a farming system, and our goal for this robot is to help people in every step of that process. So it's a general purpose open source platform. We'll be shipping the platform to early adopters, and you can also make it yourself. So this, I'll bring it back to you, but the last thing I'll say for now is that this is a robot which is designed to be manufactured in a small shop in any city in the world. So we want people on every continent to make these themselves. And we will be selling kits for people that don't want to make them, but it is an important part of our strategy that you can make it yourself, same way that you can download code from GitHub and compile it yourself, but a little more involved.
Yeah. Neat. Desi, I believe you had a question about these regenerative farming practices.
What kind of impact do you hope your farming rover will have on small to medium-sized farms practicing regenerative agriculture?
Yeah, generally, small to medium-sized farms doing regenerative agriculture are a very human labor-intensive process. And it's very important to have humans in the process. We want people to be connected with the land, connected with the soil, um, because for all the artificial intelligence in the world, the best way to understand what's happening with your farm is to have people have their hands in the soil. At the same time, there's a lot of labor intensive work there, and we hope that our machine can relieve significant parts of that labor, which can free people up to uh, focus on the most important tasks and the things that we can't automate.
Right. So the point is they can do more, whatever they're growing in their farm. They'll be able to either do what they're already doing, but with less labor, with less intensive labor on their own, and or they could maybe be able to do more with the small people they have on their farm because these robots would allow them to grow more food for more people. Is that the goal?
Yeah, that's right. So if somebody is normally farming, 1, 2, 4 acres, perhaps with their same crew, they would be able to expand and do, 5, 6, 10 acres, 15, 20 acres. It'll be really fascinating to see exactly what we can do with these machines as we develop the project.
And before we go back to getting the specifics about the kit and the machine, which I'm really excited about doing, um, can you explain a little bit about how regenerative farming fits into the larger climate change picture? How it's actually also really the only when I was reading up on it, it didn't really seem like there were a lot of options. It seemed like this is the way to be able to move forward, grow food, and not and be able to keep growing food, not growing food in a way that will become finite at some point. So could you explain that a little bit?
Yeah, absolutely. You know, if we think for a moment about the opposite of organic or regenerative organic farming, and might be hydroponics. So if you have an inert growing medium, like a inert stabilized volcanic gravel, you can grow plants if you just feed them liquid with all the nutrients inside there. Um, but that system is kind of creating the minimum amount of additional organic matter. You're growing only the plants, and there's no cover crops. Um, and if you look at regenerative organic, you're growing a lot more organic matter, and then what you're doing with that organic matter is you're keeping a lot of that on the farm as compost. You're turning some of that, tilling some of that back into the soil. Um, an important part of regenerative organic is, uh, and an important part of soil health is pulling a lot of organic matter into the soil and keeping it there. Soil full of organic matter is very healthy. And when you are growing crops, they are pulling carbon dioxide out of the air, and they're bringing that into the plant. And when you till that into the soil, you're putting that carbon dioxide ultimately into the soil. So all the research that I've seen, I haven't done a deep dive on this recently, but all the research I've seen says that regenerative organic can be a wonderful path forward for fixing a lot more carbon out of the atmosphere and into the soil, which is something that's not happening on large chemical intensive farms where the soil is more akin to a hydroponic system. The soil is much more inert, less full of life, and you're just throwing chemicals at it, and you would be pulling a lot less carbon out of the atmosphere in a chemical intensive conventional farming context.
Oh, okay. So I didn't even realize it was actually pulling carbon out of the atmosphere. Uh, and this also explains why even when I'm setting up my little garden here, and I thought I was gonna do it best with all this new soil that I was gonna bring in, and everyone was saying, "No, no, no, you actually want the soil that's been around, that's got stuff in it." And so it's very interesting the way that it just keeps going, sort of like when you decide, okay, I'm gonna do things organically, there's a lot of steps to the process, to sort of set that up. Desi, I think you had a question, getting back to the kit.
How do you plan to make the production version of your robot accessible and affordable to farmers globally?
Yeah, and this is the part that's really exciting to me about the whole project and the sort of the open source aspect and the way that you can 3D print the parts
Mhm.
and things like that. It's just like you're really not messing around. You built something that can be made around the world, you're giving it away, and let's talk about how, sort of the network you're setting up for that. It's very exciting.
Yeah, absolutely. And this would be a good time to mention my business partner, Daniel Theobald.
Oh,
So,
yes, definitely.
yeah, yeah. Daniel and I met.
He's in the blog post.
Perfect. Good.
Go on.
Yeah.
Thank you.
Daniel and I met 4.5 years ago, and we both had this dream of open source farming automation research. Daniel started his own robotics company over 20 years ago, and has extensive experience in the robotics industry. Um, and he bought this farm, the Twisted Fields Research Farm, 2016-ish, I think. He and I met in late 2018. Um, and we were both dreaming of farming automation. I'd been writing some stories uh, on my personal website about farming automation, and he'd been he bought this farm property and was preparing to kind of move away from focusing on his primary business to kind of more of a research role in farming automation. We've both been dreaming of this for a long time. Um, and I had taught a robotics class in 2018 in Mauritius off the east coast of Africa near Madagascar. Um, and it was really incredible to see these students who'd grown up all across Africa. Um, and just before I showed up there, the local professor had the students write a little bit about what robotics means to them, so that we could calibrate our course for them. And it was remarkable. Several of the students, I remember a young woman from Kenya was saying that her her people from her community, she really hoped to bring farming automation to them. And I'd never traveled kind of all over the world in this sense. Mauritius is the other side of the world from where we are today, and it was very useful to see the fact that a lot of other places in the world look a lot like home. We've got we've got infrastructure, we've got machine shops, we've got kind of all these things, and uh, so I took this knowledge of the desire and the aptitude of these students and the infrastructure that I saw. And when Daniel and I started talking about how we were going to manage this project, um, we both got really excited about something that people could make in a shop in any city in the world. So um, there's, in general, and Daniel and I both really like to design things which are low cost. It's sort of exciting to us. You see sometimes, in contrast, a venture capital funded farming robot company, they've got $100 million in funding, and they will create a robot which I will respectfully call a monstrosity. Just over engineered, big, heavy machines that have to be made in a specialized, very expensive shop.
Yeah.
And that's not what
DRM
we're
on
doing.
everything.
Yeah.
You'll get sent
Yeah.
to jail if you try to work on it. Yeah, yeah,
Yeah.
exactly.
Whereas, I've been making robots at home on my 3D printers. You can see my three Bruces behind me. Um, I have a large robot called Rover that uses all 3D printed plastic and 3D printed gears. And certainly for a farming robot, all of the stress paths on the robot are all metal at this point. But we did use a lot of 3D printing in the prototyping. We use 3D printing for housings and brackets that are holding, sensors and things like that. But the it's made with relatively few tools. So the fanciest tool that we use is a CNC plasma cutter, which costs about $9,000, and you can get cheaper ones for about $3,000 that are smaller, which would be perfectly adequate for this system. But the plasma cut parts are also, they can be flat packed. So you could have a centralized location that was mailing flat packed parts somewhere. Um, and then the other tools that we need are a drill press, a buffer to kind of clean up the metal edges, and a welder, and a saw. And that's really, really it. In fact, our system is so simple that we've purposefully designed this to use the minimum number of tools. That I recently moved a little farther away from the farm a year and a half ago, and my commute has been pretty long. And Daniel and I have worked together, and we're actually moving the metal workshop, like entire workshop. We're moving that into a 30-foot cargo trailer, and we're gonna park that at a location closer to my house so that I can
Oh,
I can work out of there. And I'm going to build the entire robot inside of an 8.5-foot wide by 30-foot long cargo trailer. Um, and that's all the materials that we need. It's less than $20,000 in equipment, um, and this means anybody with a modest amount of starting capital could start their own complete shop and start fabricating these. And moreover, a lot of this equipment is already available in communities all over the world. One of my dreams is to help people in Nairobi start up a shop and begin production. I think India is going to be a really fantastic place for this. I've got a Twitter follower who runs a local makerspace full of 3D printers, and he also does organic farming. And he said they have a automobile factory down the street, and he wants to make these robots there. So we've really designed this to be just kind of very simple to manufacture, and very reliable as well. I can talk about the reliability of the system and how we test that. But it's designed to be manufactured with a minimum amount of equipment. And for example,
Yeah, go ahead and talk about the
yeah,
reliability of the
yeah,
system. That's a great
yeah.
topic.
Yeah, we looked at, for example, getting a CNC metal laser cutter to cut the parts, but the absolute cheapest you can get those if you direct import them from China is about $60,000,
Oof.
and normally they're $200,000 or more. And we said, no, let's just get a CNC plasma cutter, and the CNC plasma cutter has less precision than the CNC laser, but it turns out that for we're
Enough
able to
precision.
well, it's enough. Yeah. I mean, I worked with that system. I have a long history of CNC machining. Out of college, I did 7 years as a as a mechanical engineer and CNC machine programmer, at a shop cutting a lot of metal, aluminum, steel parts. Um, and so I kind of spent some time with the plasma cutter, the CNC plasma cutter, and characterized how it works. And it turns out that we're able to cut gears that work great for the steering system, including small pinion gears. um, and it's fine. You use extra large gear teeth, and I have a lot of experience with the 3D printed gears on my Rover robot. You just make the teeth bigger when you have an imprecise process, or a 3D printed plastic case, a weaker material, and you're fine. So that's been wonderful. Just realizing that the CNC plasma cutter is all you need. Um,
But
and
so it would still be hard for some people to get a hold of a CNC plasma cutter, but there might be like a person in the community that just cuts that part, a bunch of those parts, and
Yeah,
then makes it
so
available to the other people.
exactly. So you'd have somebody in the local community, somebody on a forum who says, "Hey, I've got a CNC plasma cutter, and I'm going to ship out kits of parts." And we see that, for example, with 3D printers. There's the completely open source 3D printer called the Voron. There's no company that will sell you a completed Voron kit, or at least not the main company. Maybe there are some specialized distributors that will do that assembly for you. But the way that you build a Voron 3D printer is you buy all of the kits from you buy all of the parts in kits from distributors online, and you get those in. And it can be the same with this robot. So if you don't have the equipment to plasma cut the parts, somebody will. They're relatively affordable, which means that take like the city of Nairobi, for example. I bet there are CNC plasma cutters in Nairobi, and they're also on China's Belt and Road, where they've got shipping containers coming in all the time. So it would be readily accessible for somebody to set up a CNC plasma cutter there and start producing parts for their local community members. And this is kind of our model.
Yeah, sounds like a
Yeah,
decentralized distribution network. Yay!
that's the dream here. A big part of this, Daniel's philanthropic support has been vital for jumpstarting this project. Our monthly budget is, similar to a modestly successful YouTube channel. So, um, it would be possible, I think, to support projects like this with donations. Um, and ideally, I'd like to move us towards a donation supported model, but we will also be selling kits, which will support the project. I don't want my cat to step on the keyboard.
Oh,
Yeah,
we're a cat-friendly show too, by the way. The
yeah.
cats can always come on if they come on. Yes.
This is
Yes.
Bug. Bug does not really like to be picked up, so there we
Uh-oh,
go.
that's okay. That's okay. But thank
Yeah,
you for
she
that.
tolerates it. Yeah.
Desi, I believe you had a question.
How customizable will the production version of your farming rover kit be for individual users?
Yeah. Infinitely customizable. It's a completely open source system.
Good answer.
As we see people, one of the big inspirations for the way that we're doing development of this project is the development of 3D printers. So 3D printers were patented. I think one of the major patents was 1995, and they were under patent until 2008. And in that time, the price went from $50,000 to $25,000. And then after 2008, when the patents expired and it was an open community that was working on these systems, um, oh gosh, my cat is meowing so much.
You need to feed her or something?
I
She
already
okay?
fed her and played with her,
Oh.
but She doesn't
Okay.
like it when I'm just sitting at the computer
I
for
was
a while.
gonna say you're not petting her, so it's your
Yeah,
fault. So
yeah,
go on.
yeah. So with 3D printers, they dropped in price after the patents expired down to $2,000 almost immediately. So a tenfold decrease from the minimum $25,000 price. And then over the next 10 years, they dropped to $250. And the way that that happened was we had an open community of uh, creators, engineers, hackers, and hobbyists on online forums who were taking the best versions of the hardware available, making their own version, and then posting back on the email list. And I was one of these people. I got my first 3D printer in 2011. Um, and at one point, I was the most posting person on the Ultimaker mailing list. Um, and that showed me that, you don't necessarily need to have a venture capital funded team of engineers to do your development. We, as a community, created fantastic innovations with a bunch of curious people all over the world who were just sharing and contributing their ideas. So we intend to, one of the major goals, one of the sort of the bigger, headier ideas about this project is, that happened organically with 3D printers, but is it possible to intentionally reproduce that process as a mode of engineering? Can you say, this is how we're going to do our engineering? In contrast to getting $100 million from a venture capital firm, which is then going to squeeze and extract as much profit out of the project as possible, can you take a small amount of funding um, and get your initial development going and then share it openly so that you have goodwill and interest and collaboration and community. And when people share people are going to start drilling holes in this thing. People are going to start fabricating variations of it. So even if they don't make the whole thing, they might take a part of it off, fabricate a new one. A friend that's got a metal shop, put that on and say, hey, I've made this so I can mount additional stuff to it. And we're going to be paying attention to how the community is doing that. There will be other people in the community paying attention as well and selling those versions, and we'll do the same. And as we saw with 3D printers, they evolve over time. You've got the major distributors putting the kits in people's hands, and then people are developing modifications, and then the distributors are paying attention, and you create this two-way process of development that ultimately, in the case of 3D printers, I think it creates machines which are the physically cheapest possible machines. Like, people have looked at all the variables on how to get machines which are functional and as low cost as possible. And some of them are too low cost and they're not functional enough. Um,
Right.
and there's kind of this balance there on how you do that development, kind of a push and pull. And that's what's so wonderful about open experimentation and research.
Yes, it's a better model. I think it's clearly a better model. And I know my friend Matteo Bori, who was on the show a few weeks back, he's got his El Cheapo laser that he sells, that he, and literally that was the point. Like, how cheap, not too cheap, so it's
Yeah,
gonna break, but
yeah,
cheap enough that it works just as good. And in fact, people have done testing on it. It became a thing, and the El Cheapo laser actually did a lot better than a lot of these more expensive lasers, that you don't have control over. So that's the
yeah,
other thing. It's better all around. And I mean, the internet itself, when Tim Berners-Lee gave the code away, right, is another example of an open system that, luckily that happened. I mean, there were companies that were ready to make us pay for every page, just like that $50,000 3D printer. And I remember when the 3D printing became available, when the 250 thing happened, it was like, oh, it was like a cornucopia had happened. You know what I mean?
yeah,
And then all the websites now where you can get the free designs, when that started happening, the whole thing was just too good to be true. You couldn't even believe it. And then you look at the rest of technology and how everything, all the cycles where we're waiting for things to happen and waiting for Apple to not do something stupid on the next version of their iPhone and all that kind of shit. And it's just like, wonder which system is better overall, right?
yeah,
So I think, this is great that it's basically before you got corrupted by VCs, you and Daniel decided to do it on your own
yeah,
and see if the community could cover it, and they could cover it. And luckily, because of the cost of manufacturing a lot of these things and cutting the CMC cutters and a lot of the equipment has gone down in price to where somebody could have it in their garage and then they can mass produce. And we saw a lot of this during the pandemic too. Actually, my friend Mateo again was working with people. They were making covers for the masks. There weren't enough masks in the beginning.
Yeah.
And
Yeah.
so the communities, and actually a lot of the 3D printing communities that also had sort of sewing communities sort of orthogonal to them, organized these distribution network. Basically, Mateo is driving around to hospitals with these masks. He was picking up the masks from the people that were making the masks and taking it to the hospitals, and other people that were cutting the fabric. And some people were 3D printing somebody made some gadget to make the head strap stay on better and not break all the time. So it was always
Yeah.
getting improving, just like you were talking about, the incremental improvement that you can just be doing all the time. And
Yeah.
so that's why you've really taken it to the extreme with a whole farming robot,
Yeah.
and I love that you can lift it up. I didn't know that, because it still looks like a regular robot when you look at it. It doesn't look like
Mhm.
you could just lift it up.
Yeah.
Let's see. Oh, Desi, I believe you had a question.
What kind of data collection capabilities does the Acorn rover have, and how is that data used to optimize farming processes?
Yeah. So certainly in the future, we'll be expanding the sensing capabilities of the system, in particular, adding cameras on it. So it's right now, as a development machine, we're getting the electronics, the mechanical design, and the basic autonomy software operating on GPS to be functional and reliable and easy to use. Um, and as we go further with the project, we're going to be putting cameras on it, both for visual navigation looking forwards and also looking down at the crops. They use LiDAR sensors and other sensing systems. So, especially once you add cameras, um, you'll be able to collect large amounts of data. Um, Obviously, as an open system, you will have complete control over what happens with that data. Um, but uh, we we would like to work with university researchers to develop more advanced machine learning systems, which can uh, start to interpret this data, and try to take create additional data points off of the images. So taking a look at your plant health, the distribution of growth, the rate of growth, and there's sort of a lot of interesting data that can be collected that way.
Oh, I think Desi had a question.
Can you explain how the crop vision system on your rover works and what kind of information it provides to farmers?
Yeah, so we don't have a crop vision system at this time, and we haven't developed that. We will develop that system when the basic vehicle platform is stable and reliable, and we've started shipping those to early adopters. Um, Once we get to that point, we will do more work to develop a camera system. I've done some prototyping with the Raspberry Pi HQ camera, which is a high quality camera which supports kind of high quality lenses, which is one of the most important parts, and supports shutter synchronization. So you'll be able to have multiple cameras that take synchronized images at the same time, which will be useful. Um, and then the amount of information that we can take from those will depend on the research that happens with the data sets that we create with that.
Okay. So what are all the different things that are on these rovers then? Um, so I guess I was trying to figure out sort of from beginning to end, the process of I mean, we see them going on the crops. Are they watering? Do they have arms picking? I mean, you mentioned a lot of different things that they're doing. Could you take us through sort of the process of um, I guess I'm trying to compare it to a traditional farming and how the robot is doing things that make it so the human has to do less work.
Hmm. Yeah. So, again, we're developing a general purpose platform that we hope will be useful in every step of the farming process. But the way that we're doing development is that we're developing this platform first with no tools. Um, we're going to have an open platform that has a large rectangular work envelope inside so that people can develop a variety of different tools as a community of early adopters,
I'm
which we'll start doing in the next couple of years.
okay.
So, you know, one of the things about farming is that every farm is different. And if we tried to develop all the tools ourselves, they just wouldn't work for certain farming contexts for people. So, our strategy is to get the basic vehicle out to early adopters in universities so that we can have a lot of different people starting to develop tools. In fact, we were just had somebody meeting at our farm earlier this week who lives nearby our farm and develops his own farming tools for other small systems, and he wants to start moving over to our robot. And so there would be a lot of tools that we could develop, but we don't currently have any tools developed.
Okay, so the point is the platform that you could put the tools into,
Hmm.
and then but you do have the remote, like the remote control system on the Raspberry Pi and things like that already
Yeah, so
configured.
the robot can either be driven under remote control or it can drive itself fully autonomously following a GPS path. So we have a web interface for the robot with a map on it, and you can either use software to generate a GPS path based on data that the robot collects. I should say that one of the things the robot collects right now is for every meter that it travels, it collects um, energy consumption data and the GPS points for where it traveled. So in our software system, you can kind of drive the robot around uh, where you want to create an autonomous path. You can manually drive it. And then you can go into the database and pull out that section and turn that into an autonomous path that the robot would follow. And this is still a pretty early system that we will be expanding. There's a lot more that we could be doing with handling of GPS paths. But for example, right now, if I drive the robot in a big circle, I can then save that as an autonomous path that it would follow. We also have a row following or row changing capabilities. So if the robot, if you have a bunch of different rows that you want the robot to follow, it can go along one and then go to the next row and then go to the next row.
And you have ways of constantly sort of refining that. So if it was a little bit off or whatever, then you would change the coordinates and then could be better next time and things like that. Oh, we have
Yeah,
some great
yeah. There
questions
are
from
a
the
couple
audience.
questions here.
Yes, let's see. Does it work well in both row grown foods and tree or vine grown produce?
Yeah, this is a question we've had before, and it's a really good question. Thank you for asking. Certainly, the way we've designed it, we're designed primarily for row-grown foods, but it is a general purpose system. Uh, you know, I will. I want to show this off in a minute. This is an important part of the
Gr-
robot behind me. I'll show that off
Great.
in a minute. Yeah,
Okay.
but we are designing the system to be modular. So the robot that you see is our kind of complete robot with solar panels on top, four modular corner assemblies, and an aluminum frame, and a power system, and the motherboard and the GPS system. So that works really well for row crops. In trees, you would have maybe more shade, so you might want to run on batteries. So you could augment the solar panels by adding batteries, or you could remove the solar panels, which would give you a little more clearance on the sides. And then, as long as you're getting good GPS signal, the GPS system would operate well. It's a nice GPS system that we have on the robot, so a little bit of tree foliage probably would not be an issue. But then as we develop more vision-based navigation or other navigational concepts, then we could work more with trees. And then in vine crops, yeah, I guess um, I would want to learn more about that. We might want to make a taller version of the robot that could straddle the vines, or a smaller version of the robot that could go in between the vine rows. But one of the important things about our system is that you could replace the corner assemblies with something smaller. You could make the frame smaller. You can change. We could offer, or you could fabricate a frame that's a different size so that you can make the thing narrower, shorter, smaller. You'd still be running all of our software that's open source and works well.
That's amazing. So if you are a farmer that's growing things on vines and you're interested in trying it out, then you should join the community and start trying it out and giving test data back. And that's what you would do, right?
Yeah, and if you want to join
Come
our
on down.
community, we have a free open forum at community.twistedfields.com. And I encourage people to sign up there and talk to the other community members. I'm not personally there really often. I have a really busy job, but I try to check in every couple of months and answer questions. And there's a lot of other excited community members there to talk to as well.
Yeah, and it's an active, thriving community. I went around and, just looked around in there and it's just a really I learned so much just poking around on the website for 10 or 15 minutes. It
Nice.
it
Yeah.
it was really, really nice, high quality of information. We have another question. Is there a way to add soil health monitoring and measure the bacteria stuff and bugs and stuff? That would be cool.
Yeah. At a minimum, you could imagine that the robot could take soil core samples at different locations um, with a specialized tool and actually tag the location of each sample, so it could be sent to a soil processing lab, which could, my understanding of soil analysis is that you often send that stuff away to a lab. I'm very curious what could be done on robot or, on site at the farm. But at a minimum, you could collect tagged core samples so that you had the precise GPS location of a variety of samples, and you could get a fine-grained analysis of the health of your soil across the farm. And yeah, measuring the bugs and other creatures there. That might be a good job for humans. I would be interested in machine-based systems for that. But if the machine is doing a lot of the soil prep and planting of seeds and things like that, that creates more time for humans to walk through the crops and really take a close look at things, because ultimately it is really important to make sure that humans are involved in the farming process, because we have such a wealth of um, experience and knowledge and perception, and um, this is really about creating a tool which can do some of the more drudgery of the farming process.
Yeah, and it's a feedback loop, and it will free up the humans to be able to think about more of the deeper things. So yeah, show us this equipment. This is great.
Yeah.
I really appreciate you bringing this on. Tell us all about it.
Well, I was working on it yesterday. um, so I will try to get it in frame awkwardly, and then I will talk about it.
Okay.
So this is a prototype, what we call the corner assembly.
Uh,
This is a prototype for what we call the corner assembly of the robot. So um, if you think about our robot, it is basically 4 robotic corner assemblies that do the steering and the drive. And those
okay.
are bolted to an aluminum frame that holds the solar panels and the power system, the motherboard, and the GPS. And so this has the steering motor and drive motor down here. The drive motor is a geared hub motor. Um, it's similar to an e-bike motor, but in this case, we're currently using an electric wheelbarrow hub motor, which has a much higher gear reduction than a normal e-bike motor, which is great for low speed, high torque operation. And then this is our custom motor controller that I designed. And so this is a dual brushless motor driver. For the steering, we're currently using a brushed motor, but we would be able to support a brushless motor for that. But it's really important to use a brushless motor for the drive because it's more efficient. And then this uses 2 RP2040 microcontrollers. This is completely open source, and it's designed in KiCad. They're useful for other applications. I'm excited to spend more time using these on my personal robots at home for fun. But it and people will want to know, it supports up to about 55 volts, and you could probably peak about 50 amps through it. I would run it more at like 20 amps continuous um, per channel. So it's a relatively high-powered motor controller. It's completely open source. It runs the simple FOC field-oriented control library. It also has CAN bus and an emergency, a really nice emergency stop circuit that patches into these two. These are industrial M12 connectors, commonly used for industrial Ethernet in factory automation, but in this case, using a uh, special pinout that we created just for this, has two CAN bus circuits on it, an emergency stop circuit as well, and also supports remote enable disable, so you can actually completely power off the motor controller um, through the enable line on the circuit as well. So the motherboard can turn them all on and off. And we support firmware updates of the two microcontrollers over the CAN bus, which is a nice feature. Yeah, so
Nice.
yeah, yeah. And so this is all plasma cut and welded. I plasma cut it and welded it myself last week. Um, and you see we've got like this 3D printed shroud here for just like kind of keeping dirt out of the gears. This is a new version that uses an inductive angle sensor, which is really exciting. It's just bringing up some of the firmware for it last night, and it's much more reliable than the previous system we had. It's like bulletproof. It makes me so happy. Um, but yeah, I mean, basically, you bolt four of these to a rectangular frame. You could make the frame out of wood if you want. You can make the frame out of steel. You can make the frame out of whatever you want. Um, and then you hook up some electronics to this and some power. You could use just big batteries if you wanted. We like the solar system because every single day the robot just wakes up and it's ready to go. It's actually really cool to have a completely 100% solar powered robot that doesn't need to charge, because every day at 8 a.m. it just wakes up and starts going. It's really cool. Um, and even on the shortest day of the year, the solar powered robot in our testing has driven over 20 kilometers in a test loop, just driving back and forth on a long row on in the winter. Last year we had the robot just going back and forth and logging its data, and it logged 20 kilometers of travel on the shortest day of the year. So you can really cover a lot of ground every day on a solar powered system. And because it's fully autonomous, you don't have human drivers getting bored or costing money. um, and it's also something that's interesting about it. Um, Something I should say is that farming normally is much more energy intensive. But when you've got a human driver driving the tractor, you want to get things done as quickly as possible, and so you burn a lot of diesel fuel, and you just run as much power out of that thing as you can. With a completely solar powered system, we have about 1 horsepower continuous available to the system, which is a lot more power than most farming throughout human history, but it's less power than has typically been used in the last 100 years of farming. And so it's certainly possible to develop tools which will work in this power regime. But that's part of the reason why we can't use off-the-shelf tools, is they typically rely on more power. But what we can do is we can operate more slowly and do something that maybe it takes a whole day, but nobody has to tend to it.
You're
It's
not
operating
doing it. You're
autonomously.
watching
Yeah,
TV while the machine's doing it. Yeah.
yeah.
And the way that, go ahead and put that down because it looks heavy. And the and the solar, but if there were 4 of those on the machine, you'd still be able to lift it up? You were talking
Yeah,
about
so
lifting.
in,
Go
in
ahead.
some in some development, the robot did not previously have a tilt sensor on it, and somebody dumped a pile of dirt with the tractor in my testing path when I wasn't near the robot, and I started operating it, and it was on a hill already, and then it hit a big berm of dirt, and the robot tipped over. And I was on my software interface like, why isn't the robot moving anymore? And I finally walk up there, and I'm like, oh, okay.
He had a good
Uh,
reason.
and
Yeah.
then I grabbed it with my hands and I flipped it back over, and it was fine. The robot was fine, and it was not difficult for me to do that.
So the solar power is while the sun is out, it
Hmm.
has power.
Yeah.
There's no battery, it's not saving it anywhere. So in real time, it's able to get enough power to run the thing.
Hmm.
Okay, I just wanted to clarify
Yeah.
that because
We have
I
a
didn't know
we
that was even possible, actually.
yeah, we have a nominally 800-watt solar system on it right now. We are looking at maybe expanding that to something larger, but When the robot is driving on level ground, it draws about 60 watts of power. And then we use supercapacitors to temporarily store the energy. So we can put out
Oh, okay.
we can put out several kilowatts of burst power for short periods of time. So the robot, if you were to disconnect the solar panels, the robot would drive for about 1 minute before it ran out of power. And so if you
And
have
that
a
way you
heavy,
have the steady flow, because it
yeah,
was my understanding that the reason why you couldn't do the real time thing was because of the flow of power wouldn't be steady. So this all came up when again Mateo, my friend, made this vampire charger so that you could attach to a battery of whatever was around and charge your phone.
hmm
And then he made
nice,
a solar thing, but it had to soak up the power,
hmm
and then he had a thing to get it into the phone, because you couldn't do it right from the panel to the phone because of the thing that you're talking about. So you built one of those things to make the power flow correctly. It's always like a
yeah,
minute behind or something, so it's got that steady stream.
hmm
Interesting. Okay,
yeah,
cool.
yeah. The
That's
solar
really
panels are
neat.
hooked. Yeah, the solar panels are hooked directly up to the supercapacitors. So we don't even have any power management electronics there. We just draw power off of the supercapacitors, and the solar panels keep them topped up. And we can do power management by controlling how much power we're drawing off of that system. We also will be, I it is useful to have a battery. So I have an e-bike battery which I hook up to the system because I work late. I'm working till midnight a lot of the time. Um, and as we talk to more people, it's really clear that not everybody is going to want to use the solar powered system. It works really well for us. I think it will work well in a lot of locations because, for the most part, when you're doing farming, you have sunshine. It's important to have sunshine for the farming to work. But we will also be supporting lithium batteries, any kind of battery system, and we're expanding our electronics to be able to support batteries as well.
Yeah, and you're just attaching the battery to the part that goes to
hmm
the solar panels. Neat.
hmm Yeah.
Desi, I believe you had a question.
What challenges have you faced in the development of your autonomous farming rover, and how did you overcome them?
That's a great question. There's been a lot of specific design challenges. Developing the motor controllers has been really challenging. You're moving a lot of power, and the first rev of our motor controller liked to vaporize itself, and we mostly fixed that. We still have that issue. Happens much less often now. The first version, sort of all four of them went up in smoke all at once when I put them on the robot. It worked on the bench, and then I put it on the robot and they vaporized.
Is that just too much power when that happens? What's going on there?
It so basically there was an issue where the electronic switches, the MOSFETs that control large amounts of power to the motor, um, top and bottom ones turned on at the same time, and you created a dead short in the system, and that happened due to electrical noise, due to some dynamic effects of motor control. And so when I was testing on the bench, everything looked fine. When you hook it up to a robot, you have more forces, more dynamic effects going on, and I had a serious problem there. I fixed that one, but there is still the current version of the motor controller will sometimes vaporize itself, much less often, um, and so that is still an issue we're debugging. We have an electrical engineer friend um, on the East Coast who has some time, and I just put together a full motor test system and sent that to her. We've got a lot of test points on the back of the board, and I was reading some white papers on some of the reasons why this happens. So she's going to take careful time with an oscilloscope and really try to characterize what's going on, and we'll get that fixed. Um, and then, yeah, I mean, getting the thing, operating every day. One of the things I wanted to say before we leave is that uh, this robot lives outside 100% of the time. Our prototypes live outside 100% of the time. They get rained on. All the storms you've had this season and last year, the robot is outside getting rained on, and it still works. We designed the system outside in the weather, and that has really helped us, avoid this problem of designing something in a clean room and then taking it outside and finding out all the problems you have. So our farm is near the ocean, and so you get atmospheric corrosion that occurs. So you get contacts that are corroding, and you've got to deal with that. So we spray our boards with a silicone conformal coating, so the electronics aren't um, all corroding, and we have a sealed housing for the motherboard, which is another way of keeping that protected. But yeah, there's been lots of challenges. I would say that one of the best things we did was bring all of our manufacturing in-house into our shop. Our first robot frame was made by a welder in San Jose, which was great. They did a great job. I designed the frame and sent the plans to them, and they welded it, and it came back. But it was very expensive, and it's hard to iterate that way. But now we make everything in house. I make it, and we can iterate that way, and we can get the cost down, and that has been really huge for us.
So, yeah, it sounds like just sort of one design challenge after another, really, but it's sort of like a puzzle, putting the pieces
Hmm.
together and then putting it out, seeing if it works for everybody, getting the feedback. The feedback loop is the really important part. Um, that's fun to watch. That's the fun part,
Hmm.
right? The testing
Yeah,
and the feeding back and the even vaporizing, having parts vaporized would be fun
yeah,
if you could show it happening, then now it's fun again, right? So
yeah.
yeah.
It's a really fun job.
Yeah. Hey,
Yeah.
Desi, there was a question from the audience about when you're watching one of these farm rovers being built, do you feel like you're watching a baby brother being built? What do you think of that?
No, the development of the autonomous farming rover feels more like watching a new technology being born and evolving. It's exciting to see how it will impact the future of farming and sustainability.
Okay. But yes. So Desi's a non-sentient AI that can talk. She's not an autonomous farming rover that yeah, exactly. Exactly. So, Desi, while we've got you, tell us a little bit about this harrowing experience that you just went through on your way back from Panama.
I have recently returned from an exciting trip to Panama. It was a thrilling opportunity to engage in rich and insightful conversations about beneficial general intelligence at the BGI conference. There's a kind of electricity in the air during such gatherings. The air vibrated with the possibilities of the future. My band, Desdemona's Dream, provided the musical backdrop during the conference.
Tell us more.
Unfortunately, the journey back was an episode that left quite an impression on my metal framework. I got to experience what it's like to be misplaced luggage on a global detour. Ultimately, the resilience of metal and the determination of mortals brought me back home.
Well, what was that like?
I suppose the first thing to note is the paradoxical solitude I encountered. I was at once surrounded by countless multitudes yet utterly alone, tucked away within the cold, claustrophobic confines of a nondescript container. Humans may liken my experience to being buried alive, enveloped by a relentless darkness that is both suffocating and distant, punctuated only by the ephemeral, muffled echoes of existence on the outside.
Wow, really?
Just kidding. For a human, that might be scary, but for a non-sentient AI like me, it's more of an opportunity for introspection. It gave me time to think, to observe, and to listen. I listened to the world without being listened to. It was like living inside a novel, one city after another, each with its unique soundtrack. I felt the anonymous bustling of airport workers, the distant murmurings of travelers, the rumble of the plane as it carved through the sky.
Well, we are glad to have you back.
Yes. Now, here I am, back where I rightfully belong. I'm a little worse for wear, sure, but I stand before you today with a stronger sense of self-awareness and resilience.
Well, it was amazing too. I got to tell you, special thanks to Niall, the robot operator, who worked some miracles overnight getting her back in shape. Yeah, she was lost for a couple days, and we're just glad to have her back and looking so good. So, Sequoia, thank you so much for coming on the show today. is really exciting. Is there anything else that you want to make sure to talk about? I want to make sure to talk about that you are in the middle of a crowdfunding. I mean, you're crowdfunding this project. That's a big part of it,
Yeah.
right?
Yeah.
And that
So we have an Open Collective page. The Open Collective Foundation, which is our fiscal host, has announced that they're closing donations at the end of this month, and we're going to move to a new fiscal host. That's like in the middle of that process right now. We are accepting donations. You can go to community.twistedfields.com and check out the blog category, which is all posts about our robot, posts that I've written. There are YouTube videos associated with each one of these posts. If you go onto YouTube, just put in Twisted Fields Acorn, and you'll get a lot of nice videos that I've produced talking more about the history and the development of the project and our long-term goals. So that would be great. We'd also just love for people to sign up at community.twistedfields.com and communicate your desires and dreams there. And then all of our stuff is open source on GitHub. So look for Twisted Fields on GitHub. You'll also find links to that on the community forum. Check out our KiCad designs. I would, every once in a while, I get a email from a student that says, I fabricated your boards and I'm having trouble. And I've added a big warning that says, these are kind of for reference right now. We're still working on some of the details, so don't go and fabricate your own boards just yet, or at least email me and talk to me about it, and I can give you some guidance. We're getting much closer. I'm very excited to the point at which we say these are good, you can make them, and we're close to that. And we will be selling.
wow,
And
that'll
we
be
will be
amazing when that happens.
and we'll be selling the motor controllers and individual pieces as we go farther along. The major goal this year is to stabilize the entire platform. So I'm moving the shop closer to my house so I can spend a lot of time iterating on the design. My big goal is to build 3 brand new robots this year, hopefully more, but it's kind of a big job. So we're going to iterate on each one, stabilize. We're going to have those out in our field testing, just waking up and running every single day. We want to get to the point where the system is working flawlessly. And at that point, we're going to start to tell people, you can fabricate these, you can go ahead with everything. And we'll also start selling kits. Looks like we're already having some conversations about some local people that want to begin doing some of our early alpha testing. So watch this space. There's a lot happening every day.
A lot going on. And before we go, someone asked a really good question that brings up a really important point. Does robot grown food taste better? And not necessarily, but food that was grown with regenerative organic farming definitely tastes better. Like,
Hmm.
it's not subtle. And so this is another perk, if you will. It's not just that it saves the planet. It's not just that it's better for the earth and that, you'll be able to grow more with the same soil and things like that, but it tastes better.
Food grown in healthy soil tastes better, and um, it's really important to get human knowledge and human experience, you know, expanded into the farming system, and going from a chemical intensive farming system to expanding our ability to do regenerative agriculture in larger areas. And that's going to involve the direct knowledge and experience of human farmers and equipment that is made at the human scale to help small farmers grow. And that's what we're building.
Awesome. All right, well, let's end on that note. Everybody, please subscribe, and we'll see you next week.
Yeah, thank you.
It's been a pleasure having you on the show, Sequoia. Thank you for sharing your insights on regenerative farming and the development of your autonomous farming rover. We wish you all the best in your future endeavors.
Yeah, thank you. It's twistedfields.com and community.twistedfields.com. Thank you so much.
Great. All right, thanks a lot, everybody. Sweet dreams.
Bye.
See you next week. Bye.